My name is Deji Akomolafe. I'm the practice lead for Microsoft application virtualization here at VMware by Broadcom. Thank you very much for coming to my show. Want to spend the next 25 minutes talking to you about the security of your Microsoft SQL Server on the VCF platform. Now, if you don't mind me asking, is anybody here a DBA? A Windows admin? Okay. So we are mostly VI admins here. Now, thank you for that. I'm not going to kill you with PowerPoint. I'm going to show you some demos. It's a recorded demo, given that we have a very short time. And I would narrate the video to you. What I am trying to present is how you, the VI admin, can give your SQL Server admins, your AD admins, your Windows admin, the confidence they need to trust you with their workload. One of the things we're trying to achieve with VCF is that you have this one thing and everything you would like to do on your virtual infrastructure for your important workloads is in here. Okay? Before I get started, if you don't mind, I will ask that you try and please make this as interactive as possible. I want you to ask me questions. I want to be able to go back to my engineers and say, I heard this from our customers, and I need you to get this into the product. Okay? And for your participation, for your generosity, and even for liking me, I have some token here for the F1 event. You can redeem it at the front if you get one. All right, let's get on the same page first. It is very important that we understand what I am going to be presenting in the video. This is not HA. This is not high availability. Microsoft has done a very good job providing high availability capability for most of its business critical applications. High availability is not the same thing as disaster recovery. It protects against a device, a component, a unit failure, and it makes application highly available. A disaster event, on the other hand, connotes complete site outage. Not just one thing is impacted, a whole production environment is impacted. That is what I am talking about. Now, you could say, oh, Windows Server failover clustering instance, always on availability group are good enough. No, they do one thing and they do that one thing very well. They provide instance level or database level protection for your applications. If you cluster two SQL nodes together, you use WSFC as the underlying component. Whether you do FCI or you do AG, doesn't really matter. If one of them becomes unavailable, the other node takes over the workload, the active resource. That is HA. WSFC does that very well. They protect only the SQL Server, the instances, and the database. They do not protect or recover any of the downstream or upstream dependencies. You can't use AG to protect your Active Directory infrastructure. Your AG cannot recover your web server. It cannot protect your web server. You cannot use Windows Server failover clustering to simulate a disaster recovery event. Like, let's say your auditors come to you and say, show me your DR. You can't say, oh, I have WSFC, I have a AG, and let me you cannot do that. In order for you to simulate a disaster event, you have to impact production, which is very disruptive, okay? And let's say we want to get fancy. We say, okay, we can have a 3-site deployment of SQL. So we have a witness here, we have another node there, and if a site falls down, we have 2 sites. Yeah, you will have application level availability, but you don't have a DR event. A DR again connotes site unavailability, a complete unavailability of a production site. Now, I work for VMware by Broadcom. I work for Broadcom. I've been here for some years. I've talked to customers every day. That's what I get paid to do. I'm your trusted advisor, and I'm telling you right here, right now, there is nothing in VCF, in vSphere, that replaces WSF, CAG, or FCI. We do not do application level HA, okay? I have to make that distinction so you don't tell me or you don't go away from here thinking, oh, well, we can use vSphere HA. No, you cannot for application level high availability. All right, let me do a quick description of what HA looks like. Here, you have a cluster of VMs running SQL in a 3-node host. Life is good. Everything is working. Node A is active right now. If something happens, node B will be active. Now, let's say a host goes kaput, unavailable for any reason. vSphere HA is there. WSFC is there. The first thing that's going to happen is WSFC AG or FCI will move whatever was active on the VM that was on this host, move it to the next VM. In less than a minute, you're back with access to your database. That is HA. That's application level HA. Now, at the same time, that VM that went down with the host gets restarted automatically, okay? Gets powered on a surviving host. So that VM also becomes available. WSFC sees that and says, okay, welcome back. Now you can participate in the cluster. You following me? All of that is HA. This is a disaster. Are we on the same page? Now we have a crater where those VMs and the hosts and everything supporting it used to be. It's gone. That's why we're here. I'm not selling you on a product. I am talking to you about the feature in VCF or the component in VCF that gives you the peace of mind you need to easily configure complete, repeatable disaster recovery infrastructure for everything that matters to you. I'm going to ask you a question, if you don't mind. Who's familiar with Site Recovery Manager? Thank you. It's been around for a very long time. We call it VMware Live Recovery now. There's a second component to that which I'm not going to talk about. We are going to talk about site recovery. And here's where my video comes in. Please bear with me. VLR provides a simplified, and I'm not exaggerating. It's very simple, and you will see it as I go through this demo. A simplified opportunity to configure comprehensive and repeatable disaster recovery for your important workloads. We are going to use a cluster of SQL Server. Remember, it's already protected by HA. But we're also going to do something else. Because we are, I'm sorry. Nice one. Who said that? You got a token. I need to swim. Do I need to exit? Do I need to exit the PowerPoint first?
Is it PowerPoint?
It's not PowerPoint anymore. I want to edit from the PowerPoint.
You gotta exit after you got the video.
Okay. Do I need to close this?
Yeah, now play the video.
Okay, thank you.
So you have here, go into your settings because you're using your own computer. So go into your settings, you got a mirror.
Thank you.
So when you go back here, you have to do that same thing.
Okay, thank you. We're good. Thank you very much. All right, that was operator error, and I apologize. Okay. I'm going to do, in this video, I'm doing something else. Remember, recovering the SQL Server doesn't do you any good on its own if the supporting infrastructure is not available. So we're going to use Live Recovery Manager to recover the clustered SQL servers and the domain controllers that support them. Okay? So we have two domain controllers here. We have live site recovery deployed at the production site and at the DR site. Okay? We've created protection groups. The protection groups are the unit of recovery in LVR. Here is our domain controller. Here are domain controllers and the SQL servers. They've been replicated by either a vSAN infrastructure or storage, a vSphere application, or a storage array adapter by a third-party vendor. One way or the other, the copy of the VMs that we're protecting needs to get to the DR site. How you do that is outside the scope of VLR. Now, where are we? This is our SQL cluster. Just showing you that we are not hiding anything here. The active node is 01, and all the resources are active right now on that single node. By the way, even if you hear active configuration in SQL, the database can only be active on one of the nodes. So we are going to focus on that node. It's very important. So you will see some of the things that we do to bring up the active node first and ensure that we can force quorum to start. So SQL Server cluster. Here is us running some queries. This is just showing you a normal production environment, a normal day. The instances are up. The nodes are participating. You see the primary, you see the secondary nodes. You see the queries running. You see everything happening on these three VMs. Okay. Two protection groups. Why did I create two? Because I have two different workloads that I want to recover, right? So one is for the domain controllers, and the other one is for the SQL Server. I want to get the domain controllers ready first before I bring the SQL Server because I want the infrastructure to be available. So I also create a recovery plan. The recovery plan is where you fine-tune your playbook, your recovery playbook, everything you want to do. In this case, for example, we're going to look at recovery plan 01 for the DCs. Now, please pay attention. This gets a little bit complicated. By default, VLR lets you change IP addresses. However, we cannot change the IP address of the virtual IP for the cluster because it's not bound to TCP, any NIC inside the guest operating system. So we're going to do something else for that. Please bear with me. So we can change IP addresses automatically. We can configure what we want it to be. If you have a stretched subnet, then you don't even have to do this, okay? But usually the DR side has a different IP subnet, and when VMs get there or when workloads get there, we re-IP them. That's what we're doing here. There are priorities also. Priorities tells VLR, I want you to recover this VM first before you recover this other VM. And when this VM is ready, when you check the VM tools and it's pinging, you can recover the other guys. Flexibility. Now, I'm going to pause this. When you create a cluster of SQL Server, WSFC, your application owners, your end users don't connect to the individual nodes anymore. They connect through a virtual IP, the cluster IP. That's how they interact with that cluster. Here is a DC. In 2012, Microsoft introduced what you call VM Generation ID. It's a way to ensure that you can virtualize domain controllers safely. We don't have the time to get into the intricacies here, but some things happen because of VM Generation ID. If you recover a domain controller, that domain controller becomes, at least for the brief moment when it was recovered, useless. What happened is, in a virtual environment, a domain controller, a VM, gets a generation ID. The hypervisor gives it a generation ID. It's just a number, some numbers. That number persists over the life of that VM, okay? That number is surfaced to Windows. Windows uses that number, that ID, to track the state of that Windows operating system. If it's a domain controller, that number becomes doubly important because any change in that tells Windows that you need to take some actions to protect yourself. What the domain controller does first is it loses its identity. If the generation ID changes, it's no longer a domain controller. It loses its read pool. A domain controller that doesn't have read won't let you create any object in AD. It can't even advertise itself as a domain controller. This complicates disaster recovery. And these are things you need to factor into your disaster recovery plan if you are going to ever recover a domain controller. It is virtualized. We replicate it either with a vSphere replication or array replication. It goes to the other side. When we bring it up, it's a different VM. Its generation ID changes. When you power it on, it loses its identity. So you need to do something. I have a very long blog on this. If you go to degify.com, you'll find it. Because the DC is no longer a DC, now we're a host, right? We are recovering 2 domain controllers. We have a crate in our production environment, and we don't have anywhere to go. Well, luckily for us, Microsoft made it possible so that you can do 2 things. You can either force NTDS to start, or you can just keep rebooting the VM. There is another complication. When the domain controller starts, the first thing it wants to do is find a peer, another DC that it can synchronize with. If it can't find any, then it doesn't know that it's a domain controller. There's a registry key you can use to disable that behavior, but I wouldn't recommend that you encourage your AD admins to do that. But all of this is telling you that recovering domain controller is complicated. What we do in our recovery is we put a PowerShell script inside the domain controller, and we are saying, when we recover you, we just want you to reboot a few times. When you do that, Microsoft lets you stabilize that domain controller if it is the PDC emulator or the read master. Eventually, it begins to advertise itself as a domain controller. That is what we are doing here. We are calling a PowerShell script inside the VM. It's just PowerShell.exe run this PS1 file. I'll show you what's in that PS1 file. So what I'm showing here is you can run ingest script easily with VLR. All right. This is domain controller 2. Again, we can do its IP. What we are doing to domain controller 2 is we are telling it, even though it's priority 1, we are telling it to wait until we fully recover DC 01. Because if that guy, if 02 starts, it doesn't have any feasible role, it doesn't have any identity. We want it to wait for the DCs to be recovered. All right, so for the SQL Server, we are also doing some things. We are also doing, we're doing scripting inside to re-IP the virtual IP for the cluster. Also, just PowerShell script. We're just saying call this script when you're recovered. Let me fast forward. For the second one, the second SQL Server, we say don't start, don't get recovered until the first SQL Server has been recovered. Now, this is the PowerShell we use for the domain controller. As you can see, the only thing we're doing is shut down and reboot. Nothing fancy. All right, so we are getting a little bit complicated with the SQL recovery. And let me explain what is going on here. When we recover SQL, there are 3 nodes. Okay? When they come up, the cluster is going to be down. We've changed the IP addresses of the VM. You saw that. We now need to force the cluster to start. Luckily for us, it's a very simple command: start cluster node -F and a Q. Okay? And we're then changing the IP addresses of the resources, the VIP, the listener, and then we are restarting all the services so that the cluster can come up. That is all we're doing with that PowerShell script. And VLR makes it very easy for you to call ingest script. Everything I'm talking about here is documented here, including the sample script I've been using here. Now, I'm skipping, please. We're going to now recover the domain controllers. We're going to run. We can do a test. The test is what helps you verify your recovery settings. You can do this repeatedly without impacting production. You fell into a fenced-off network. Sorry, skipping ahead. Now we're going to do a real failover. Well, because we manually initiated this, we want to confirm that this is what we actually want to do. And what is going to happen is LVR is going to go ahead and power on the first DC as we configured. You can see them here. It's part of the DC on the production side because we are doing this manually. So the first thing it does is shut down everything on the other side and bring them up on this side. And So, our domain controllers are recovered. Now, the SQL servers are going to get recovered as well. And everything we've pre-programmed into that recovery steps is getting executed. So I ran out of time. I'm sorry, they're telling me. I apologize. I thought I had enough time. I can be out there if we want to take this offline. Yes. Two minutes. Okay.
Quick question. How do you throttle replication traffic during business hours?
That would be your storage replication, and we also have a way you can configure what your RPO should be. You could be every minute, it could be 24 hours. So you have a very long window to say how frequently you want to replicate the VM.
I want to continuously replicate, just throttle the amount of data that's being replicated.
Yeah, sorry, I have to beg off that question. Any other one? Sorry, I can. All right. I apologize for running out of time. My videos are always available, and my decks are always available. Deji.akomolafe at VMware at Broadcom.com is my email address. Please let me know if you need to see this. Thank you.